Alright, here we're going to take a look at Exam 1, Section 2, Part B, Problem 6, Part C, where we're looking for dA dt. Now they told us that k was equal to 1/2, and that dk dt, or the rate of change of k, was equal to 1 over pi. And we know from previous parts of the problem that the area is equal to sine of x minus kx. So dA dt is equal to cosine x times dx dt minus dk dt x minus k dx dt. Okay. Well, we know that k is equal to 1/2, and we know that x is equal to the inverse cosine of k. So if k is equal to 1/2, that means that x is equal to pi over 3. Okay. So we've got some values here. We know what x is, so we can find the cosine of x. We know what k is. We know what dk dt is. What we don't know is what dx dt is. But we can find that out. Alright. So we know that x is equal to the inverse cosine of k. So the cosine of x is equal to k. And if we look at a very nice triangle, there's angle x. Cosine is adjacent over the hypotenuse, k over 1. That makes the opposite side the square root of 1 minus k squared. Okay. There we go. So now, if we take a look at cosine x equal to k, derivative of cosine is negative sine of x times dx dt. Can't forget the chain rule. Derivative of k is dk dt. Okay. So, let's see. dx dt is going to equal dk dt times 1 over negative sine of x. Well, dk dt we said was 1 over pi. We said that x was pi over 3. So that's negative square root of 3 over 2. So that becomes 1 over pi times the square root of 3. And let's put times 2 up here and make that negative. So it's negative 2 over pi square roots of 3. Okay. So now we know what dx dt is when k equals 1/2. Let's come back over here. The cosine of pi over 3 is 1/2. dx dt was negative 2 over the square root of 3 pi. Minus dk dt was 1 over pi, and x was pi over 3. Minus k is 1/2. dx dt is negative 2 over the square root of 3 pi. Hey, look at that. This thing and this thing cancel each other out. Oh, and so does this pi and that pi. And that would give us negative 1/3. Okay. It's a little involved, a little confusing, but hey, you'll find it. Good job. And that, of course, is Mr. Phillips bursting in on our video. Thank you. You are now going to be on YouTube. Thank you.
It's pretty.
Sir, you're going to be on YouTube.
That's cool. I think you'll know what I mean. It makes sense, right?
Yep.
All right, I'm gonna find someone else from the other field. So, thank you.
No problem.
How do I get into these things?
I have no
How do I get
idea.
out of these things?